All right. So before we begin diving into expressions that have both variables and exponents, I want to take some time just to really hone our skills working on exponents in expressions without any variables. So if you read the instructions here, once again, this was one of those activities that in class, one student would have completed the left column, another student would have completed the right column, and then you would have checked each other's work. The reason is that for every row, the answers should be the same. So, before we begin diving into this, once again, as always, when you work on these videos, please feel free to just pause or try and complete the whole entire activity first, if you feel ready to do so, and then just watching the video to check your work. However, if you're really struggling with this and you feel like you need to watch the video, watch as much of it as you want before going ahead and starting on that independent practice. So, let's look what we have here. So 5 squared plus 4, so there are multiple operations happening here. Whenever there's multiple mathematical operations happening in a given problem, we need to remember our order of operations. Okay, so that is the order in which you complete an operation in math. And that word we think of is PEMDAS. We say, please excuse my dear Aunt Sally. Parentheses, exponents, multiplication and division, addition and subtraction. So, if you have any of these things, whatever letter comes first, you better do that operation first. So right here, we have 5 squared plus 4. I don't have any parentheses, but I do have an exponent, so I need to take care of that first. 5 squared is 25, and then I can add 4, and I would get 29. If I did the same thing here, so I have an exponent, 2 squared is 4, plus 25, I get 29. So once again, it's showing that every row, the problem in the left column and the right column will be equivalent. Here we have 2 to the 4th power times 5. So once again, exponents does beat out multiplication, so we need to do that first. Since we're kind of beginners with exponents, I think it's always helpful to write that expanded form first. 2 times 2 is 4, times 2 is 8. Times 2 is 16, so then this would be 16 times 5. 5 times 6 is 30. 5 times 10 is 50. Put those together. This would be 80. Same thing here, expand form, 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 10, and we're getting that same answer. Okay. Whipping down. So here, this is just squared, so I just know that's 4 times 4, which is 16. 3 times 16 is 48. I'm just going to go through the left column, and you can solve these independently. 2 to the 3rd power, expanded form. 2 times 2 is 4, times 2 is 8. So this is 20 plus 8. 28. 9 times 2 to the 1st power. Any number to the 1st power is just itself. That answer is nice and simple, 18. All right, now we're starting to see fractions and exponents together. No big deal. So once again, we could just write this in expanded form. This is 1/2 to the 3rd power, so that's 1/2 times 1/2 times 1/2. 1 times 1 times 1 is 1. And then when you multiply fractions, so the numerators just multiply together, and I kept 1. Now my denominators need to multiply together. 2 times 2 is 4, times 2 is 8. So 1/2 to the 3rd power is actually 1/8. And then we have to multiply that by 1/9. 1 times 1 is 1. 9 times 8 is 72. So this would be 1/72 would be my answer there. Okay. So, now, on the other side of this paper, well, you're doing this digitally, so I guess you're not even really flipping the paper. So the next page that we're going to cover on this video is what's the value, okay? So it says evaluate each expression for the given value of x. So once again, we are being given values for a variable. So a value of a variable is when a variable has a number attached to it. So x in this case is 10. So if they give you a value, that means we are going to substitute anytime you have a value for a variable, it's telling you x equals 5, y equals 12, whatever. If they're giving you a number for that variable, you need to substitute that value in to solve. Or in this case, they're using the word evaluate. So, instead of 3x squared, I'm going to replace x with 10. So, once again, ask yourself, what are you going to do first? Are you going to do 3 times 10, or are you going to do 10 squared? So once again, multiple operations at play. We need to remember our order of operations. Exponents comes before multiplication, so you need to make sure you do 10 squared first. That would be, if we wrote that in expanded form, that would be 10 times 10, which is 100. Answer, 300. Okay. So, next one. So, same original expression, but this time our value for x is different. It's 1/9. So once again, I'm going to go through that substitution step. And then, do I do 3 times 1/9 first? No, I do not. Because I've got this exponent. Exponents beats multiplication. I need to rewrite this in expanded form first. That would be 1/9 times itself 2 times, which would be 1/9 times 1/9. Multiply the numerators, I get 1. Multiply my denominators, I get 81. So this would be 3 times 1/81. That would be 3 over 81. Technically, you got a fraction with a really big denominator. Always check if it can be simplified. It indeed can. The GCF there is 3. Whenever you find the GCF to simplify, you divide both sides of your fraction by that value. 3 divided by 3 is 1. 81 divided by 3 is 27. So that would be your answer. So once again, always a reminder, feel free at this point, if you haven't already, to pause, go ahead and try and solve these problems independently so you are pushing your brain, making the most out of this activity. Alright. Here, x cubed over 4. Alright, so I'm going to rewrite it. I'm going to substitute in. I'll do it down below. Okay. Then I'm going to write it in expanded form. So, first step, second step, third step, 4 times 4 times 4 over 4. That would turn into 4 times 4 is 16, times 4 is 64. So this would be 64 over 4. And then to simplify that, can 64 be divided by 4? Indeed, it can. It would be 16. So remember, fractions are division. So this is kind of like an appropriate approach to take, where you rewrite the expression, you show that substitution, we're showing that expanded form, and we're showing how we simplify to get our final answer. So once again, same problem, same expression rather, but we're substituting in 1/2 instead. Okay, so here's my substitution. Up next, we got to do our expanded form. So this is 1/2 to the 3rd power. So that would be 1/2 times itself 3 times. 1/2 times 1/2. So I can see here, all across the numerators all multiply. That's just going to be 1. 2 times 2 is 4 times 2 is 8. So that's 1/8 over 4. So fractions are division, but what is 1/8 divided by 4? Well, whenever we divide, especially with fractions, we can always keep in mind the old keep, change, flip. So if I wanted, I could rewrite this as 1/8 divided by 4. Okay, 1/8 over 4 is the same thing as 1/8 divided by 4. And then we're going to keep that first number. We're going to change the division to multiplication, and then we're going to make our final number its reciprocal. So let's remember, any whole number is just that number over 1. So the reciprocal, flipping them, the reciprocal of 4 is 1/4. If I multiply it across, that would be my answer. So yeah, always important to know, anytime you do division, you can change division to multiplication, if as long as you make the second number its reciprocal and get your answer that way. Okay, because we never really talked about dividing a fraction by a whole number. Anytime you don't feel like doing division, turn this guy into its reciprocal, multiply, got your answer. All right, next one, 9 plus x to the 7th. I'm going to replace or substitute x in for my value of 1. So if you wanted to write this in expanded form, that's 7 ones. Well, guess what? 1 times itself a trillion times, or 7 times, is always going to be 1. My answer is 10, right? 1 to the 7th power is 1. 1 to the millionth power is 1. Any repeated multiplication of 1s, you can multiply 1 times itself over and over again. That's all you're going to get. All right, and now the final one, 9 plus x to the 7th, but this time we're replacing x with 1/2 once again. So that's 7 1/2. 2, 3, 4, 5, 6, 7. And once again, we do know that, so when you multiply fractions, numerators multiply across. So this is just going to be 1 on the top. Denominators, a little bit more work. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. Adding a whole number to a fraction, that would just be a mixed number. So 9 plus 1 128 is just 9 and 1 128. All right. So check your work, and then we'll move on to our next activity.